In this lesson, we're going to see what multiplication of a number does to a graph. So again, we're starting with the function f of x, but this time we're going to multiply the function by a number c. The number could be bigger than 1, or it could be between 0 and 1, and that's going to give us two separate cases. For example 1, notice that the number c is outside of the function. So this means that we're going to be adjusting the y value in some way. So the graph that we're starting with is the square root of x. And just as before, if you're changing the y value, it's going to change it in the exact same way that you would expect. So I'll start with y is equal to 2 times the square root of x. What this will do is double all of the y values. So if we start at the point 0, 0, well, the y value is 0, and if you multiply it by 2, it stays 0. Now let's just pick a couple of other points. Here's the point 4, comma 2. So the y value is 2, and if we double it, it's going to go up to 4. So I'll put 4, comma 4, and maybe a couple of others. Okay, I know the square root of 9 gives me 3, and if we multiply the y value of 3 by 2, it's going to go up to 6. So I can plot that value, 9, comma 6. And one more, I'll look at the square root of 16, which is 4, and if I double 4, that's going to go up to 8. So I'll plot that as well. If I draw the graph going between these points, it looks like this. That is the square root of x multiplied by 2. So the net result is that we doubled the y values. So I'll just put double the y values. Now, if we compare this to y is equal to, okay, this time it's going to be 0.5 the square root of x. This is the same thing as saying 1/2 of the square root of x. Same thing, but now it's a number between 0 and 1. What this will do is multiply every single y value by 0.5, or said another way, it's going to divide all of the y values by 2. So if we use the same points, I think we're going to get a little bit of overlap, but if I start at the origin, the y value is 0, and if you divide that by 2, well, that stays 0. So those all meet at the same point. But now, if you go to the point 4, comma 2, and divide it by 2, it goes down to 1. If you go to the value 9, comma 3, that's going to drop down to 1.5, because we're taking half of 3. And just to get one other value up here, okay, we had 16, comma 4. The y value is going to drop down to 2. And if I draw the graph going between these points, this is the equation that I get. So this one is, I actually wouldn't call it a stretch, but this is more of a shrink. This thing is getting closer to 0, but that makes sense. Every y value was cut in half. So let's actually refer to this as a shrink, whereas the one above it was a stretch. But the idea here being, okay, if we multiply by 2, doubles the y values. If we multiply by 0.5, cuts them in half. And anything at 0 remains at 0. Now, in this second example, we're not going to be multiplying the y values by a number, but instead we're adjusting the x values. So again, we're starting with a function, but this time the value c is being multiplied directly to the x, so it's like within the function. This should change the x values in some way. And I think we'll consider two separate cases, a number that's bigger than 1 and a value that's between 0 and 1. So we're still starting with the square root of x, that's the original function here. And I think I want to look at, let's look at this one first. Y is equal to 0.5x. So as I said before, anytime that you're adjusting the x values, it's going to go in the opposite way that you would expect. So in the previous example, 0.5, it cut every single every y value in half. So 0.5 here is gonna not cut in half, but this is gonna double. So I'll jot this one down too. This is gonna double the x values. And if we look at our graph, here's what it means. The x value here is 0, 0. So if I double the x value, it still is at 0. But if we check out, let's say, here's 4, 2. The x value is 4. If I double the x value, it's going to go out to 8. So this is going to be the new location, 8, 2. If I maybe just pick one other point, here's 9, 3. If I double 9, that's going to take me out to 18, which is over here. So I now have the point 18, 3. And the entire graph that we get looks like this. Every single x value is doubled. So the one that was at 0 stays right where it is. The one that's at 4, 2 goes out to 8, 2. And the one that is at 9, 3 goes out to 18, 3 to give us this graph. But the real question is, like, why is this happening? To see this, we can just choose a couple of the values that I have. So I'm going to use this one. This was the value 8 for x and then 2 for y. If you put 8 into this function, what you're saying is you're going to the function, you're placing 8 into x, and you're simplifying it. Well, 0.5 times 8 is 4, and the square root of 4 is 2. The reason the value doubles is because it takes you back to 4 when you multiply these two things together. Doubling it, you kind of want it to cancel with the 0.5. So we can check this out with the other value here was 18, 3. If you put 18 into this function, that's the square root of 0.5 times 18. But 0.5 times 18 gives me 9, and the square root of 9 is 3. So that's why the value is going to be 18, 3. So in every single case, we're just doubling the y value. Now, if we compare this to y is equal to the square root of 2x, this is going to cut every single x value in half. So this will take half of the x values. So I think the graph might get a little crowded, but I'm going to try to put this up here. If you have an x value of 0 and you take half of it, okay, you're still going to be stuck at 0. So again, they're all overlapping at 0, 0. But if we look at the point, let's see, where was it? 4, 2, and we take half of 4, it's going to go here to 2, 2. And maybe I'll just use one more that we haven't before just to get a new value in here. If you look at 16, 4, and you take half of 16, that's going to drop you down to 8. So we get the point 8, 4. We get enough points, and then the graph looks like this. All of the x values are moving towards the y-axis because you're cutting all of the x values in half. So I guess the takeaway from this is, if you're multiplying by a number inside the function, it's going to still do the opposite of what you'd expect. So this did not double the x value, it cut it in half. This 0.5 didn't, it actually doubled the x value as opposed to cutting it in half. And for the final example, we're still starting with the square root of x, but now I just want to combine all of these ideas just into one function. So from the square root of x, which is this equation here, what would the graph of 2 times the square root of x minus 5 plus 1 look like? So we'll do that in blue. And just as before in the previous lesson, I'm going to mark down the things that are different between the functions, list out what they should do to the graph, but keep it in the appropriate order. So if I look at this brand new function, there are three things that are different. There's a -5. That means I'm subtracting 5 inside the function, so it's changing an x. This 2, that's outside of the function. That means I'm going to multiply all the y values by 2. And lastly, this +1, which is also outside the function, means, okay, you're going to take your graph and go up 1. And that is the order in which it will occur. In terms of order of operation, you would work within the function. You would then deal with multiplication, and then finally addition. Things outside of the function change your y values. Things within the function change the x's. So if I list all of those out, the first thing was that x minus 5. Okay, so this x minus 5 changes the x value, but it's going to be the opposite of what I expect. It doesn't go left. This graph goes right 5. Okay, the second thing that happens is now this 2. This is changing my y, so I'm going to double all of my y values. I think that's the note I'll make here. We're going to double the y values. The last step is the +1. That's also changing my y's, and this means I'm going to go up 1 place. If I now look at my graph, I'm just going to pick a couple of points and run it through these 3 steps, enough so I know what the final graph will look like. So I think the points I'll use, let's use, how about 0, 0, 4, 2, and 9, 3. Okay. So starting at 0, 0, if we go right 5 places, that means I go to 5, 0. If I double the y value is 0, so 2 times 0 doesn't do anything, it stays right where it is. And then if I go up 1 place, I'm now at 5, 1. So this new function that we have, it took the point at 0, 0, it goes over 5, doubled the y value, which didn't move anything, and then went up 1 place. All right, let's do the same thing now for 4, 2. If I go right 5, that's going to go over to 9, 2. If I double the y value, that's going to go to 9, 4. And if I go up 1 place, that's going to go to 9, 5. Okay, and one other. Let's see. Let's check out 9, 3. Again, if I add 5 to it, that's going to go to 14, 3. If I double it, it goes to 14, 6 because I'm doubling the y value. And if I add 1 to it, that's going to be 14, 7. So you can get as many points as you need, but just with these 3 here, I think I get the general shape of the graph. It's going to look like the one I start with, going through these 3 points. So this is my graph. The whole thing moved right 5 places. It then doubled all of the y values and then moved that entire thing up 1 place.